Hello, I'm Pushkar, Master Teacher Chemistry in Vedantu. I'm going to discuss problems of JEE Advanced Chemistry 2020. Let's solve the problem number 7 in paper 1. The problem is related to thermodynamics, and this is a problem in which real gases concept is also involved. Let's move on to see what is the problem. In thermodynamics, the PV work is given by W is equals to minus dVp external. For a system undergoing a particular process, the work done W is equals to given by one expression. The equation is applicable to this multiple choice problem. System that satisfies the van der Waals equation of state, process that is reversible in isothermal, and process that is reversible in adiabatic, and process that is irreversible and at constant temperature, that means isothermal. So the idea in this problem is that we have to see that which option is correct. So let's start with the reversible expression of reversible work. As we know, a reversible work is given by the expression dW is equals to minus P external into dV. This negative sign is very peculiar for the chemistry. It will take care that work done on the system is always positive during compression and work done on the system is always negative during expansion. So that is why the negative sign is there. You can check it out. If the dV is positive, then it's going to be, the work is going to be negative. dV positive means expansion. Okay. Now, as you can see the expression, this expression is containing RT upon V minus B minus A upon V square term. If you remember the van der Waals equation of state, that is P plus A upon V square, V minus B is equals to RT for 1 mole of a gas. So if you look carefully, we can write this expression like this. P is equals to RT upon V minus B minus A upon B square. So clearly, the pressure of the gas, real gas, can be written like this. And if the pressure of the gas can be written like this, then dW is equals to minus P external into dV. If we write it like this, then we are going to get the same expression as given in the problem. RT upon V minus B minus A upon V square into dV. And if you integrate it with proper limits, you're also going to integrate the dW in the proper limits, and that is going to yield you the work. So what kind of work is this? Is it a reversible work or irreversible work? Of course, it is a reversible work. What is the status of temperature? In this expression, can you see this temperature? This temperature has been kept as a constant entity. Otherwise, that will also be a variable and we'll have to take care of this. So during this process, this is assumed if we're calculating work by this expression, that means temperature is already constant. So can we select this process that is reversible and isothermal? Of course, B is the correct option. System that satisfies the van der Waals equation of state? Of course, this is true only for a system which is applicable, which is following the van der Waals equation of state. Process that is reversible and adiabatic. Can we say that this work is related to the adiabatic work? Can we say that? What is an adiabatic process? An adiabatic process, Q is equals to 0. So if you're talking about a real gas, so in case of real gas, du is equals to, you will write d delta W, or in differential term, du is equals to dW, since Q is equals to 0. But since the gas is a real gas, the W expression will be given by dW will be given by minus P external into dV, and once again it is going to be the same expression, minus RT upon V minus B, negative sign, minus A upon B square into dV, and integral of this will give you the work, and du is equals to this. By using this expression, we can relate or we can deduce something about the adiabatic process. But when we apply it for adiabatic process, then as we know, the T is going to change, because during adiabatic process this T is going to change, and it is slightly tricky because in adiabatic process du is given by Cv into dt plus A upon V square into dV. We could not discuss right now why it is written like this, from where this term is coming, but as a result, if we take it for the justification of this problem, so that is equals to minus RT upon V minus B and minus A by V square into dV. So you can see that this term is going to be cancelled. So we are left with what? Cv dt by t is equal to, with negative sign, RT upon V minus B into dV, and upon integrating it with proper limits, we are going to get an expression like this: Cv ln T2 by T1 is equals to R ln V1 by B minus V2 by B. So by solving this expression, you are going to get a very similar thing like you get in the ideal gas, but that expression will be for the real gas. So conclusion is this, that of course this can also be chosen, process that is reversible and adiabatic. That's also true. But the D option, process that is reversible and at constant, that means process that is irreversible and at constant temperature, that means isothermal, it could not be justified by this equation by any means, because in case of irreversible process, the work will be given by W irreversible is equals to minus V external into V2 minus V1. So we could not justify it. So clearly the option D is incorrect option, and we can choose option A, B and C. Thanks for watching. Stay tuned for next question.